session. Today we are going to talk about the Crosswork Network Controller, or CNC in short. And CNC is an SDN controller for the IP transport network, and it's really a turnkey automation solution that helps to manage a breadth of service lifecycle functions, right from provisioning, visualization, monitoring, optimization, and troubleshooting. I'm Deepak Bhargav, product manager for the CNC, and also with me is Krishnan Thirukonda. He's the technical marketing engineer. He's going to show the product in action and some of the innovation that we are quite excited to share with you, where you will be able to experience it and you can see how it helps to improve the users or the customers, how they can improve the service agility, reduces the operational cost, as well as improve the end user experience. So now let me talk about the Crosswork network automation. And the goal there is that we want to simplify the service lifecycle functions through closed loop automation. And that is based on three key pillars. And these three key pillars you'll see are embraced into any of the offerings that we have in the portfolio. And these are basically the visibility, insight, and actions. And visibility is really about understanding what's going on in the network, what's the state of the network, how the service is performing, are they at the risk of meeting the SLAs, are they degraded, or how the devices are performing, are there any topology changes, any alarms that I need to watch for, and so on. But that visibility itself is not enough. We have to transform that data that we are collecting into some meaningful insights and things that are operationally of significance. So that is where the insights come into picture. For example, if I'm monitoring with the controller the bandwidth utilization on the interface, what I really need to know is it going to result in congestion? Or if I'm monitoring the latency, I want to know whether it could, put the SLA at risk. Or if I'm monitoring the errors coming from the hardware, does it tell me whether maybe there could be potentially a hardware failure? So that's the kind of insights we need to draw so we can take appropriate steps as a part of the closed loop. And that's where the action comes into play. So if, for example, if I am watching the network and I'm seeing topology changes or congestion creeping up, I may want to take steps where I can redirect some of the traffic on alternate paths so that I have enough capacity on the link which is carrying the traffic that may have SLAs with it. So those are the kind of steps. Or even, let's say if I'm watching the link and I'm seeing a lot of link flaps happening, I may want to detect that and say, well, it seems to be suspicious, and may want to shut the port. So you need to take some actions. And there can be a whole bunch based on the kind of observation and the insight you can gather from the network. So now let me walk through the components in the portfolio, and you can see that there is breadth of capability that helps to address the functions across the typical operational lifecycle, right from the plan and design. Like that, we have the WAY, which is the WAN automation engine. That's basically an offline planning tool. It models the network and allows you to overlay the demands, different scenarios, run what if analysis based on the simulation. And the goal there is that you're able to design the product that's kind of right-sized based on the anticipated demand. Then we have NSO. NSO is the foundational component of the automation of this automation portfolio because it helps in automating a lot of day-to-day configuration tasks. It also, the key thing is that it helps to abstract the complexity and the heterogeneity of the network and to present a simple, open, programmable interface that helps to facilitate automation, which is typically done expressing the intent. And when the intent is expressed like Yang models, whether it's device changes, service-related changes, it can then be implemented at a mass scale across the network. And then we have EPNM, and EPNM plays the role of the EMS and NMS in the Cisco network. Then let's go deeper into the controller. You see three key components: the Crosswork Network Controller, which I mentioned is a turnkey solution that addresses, the use cases automation task across the different service lifecycle functions. Similarly, we have the controller for the optical domain. And that is called the ONC, or the Cisco Optical Network Controller. And what we also have on top is the Crosswork Hierarchical Controller, which helps to stitch together the information from different domains to deliver a unified end-to-end and multi-layer view. And why is it important to have that? Is because often when the services are deployed, they could run across multiple domain. And as you're provisioning the services, you want to have that end-to-end view, and that intent, the service intent, translated into the requirements for a specific domain that can get provisioned. Similarly, as I'm monitoring the services, I want to have that end-to-end view, and that the hierarchical controller constructs it based on the data it gets from specific domain controllers, and be able to track the health of the services, and then be able to decompose or figure out if there is an issue or where the issue could be coming from. So those are some of the advantages that the hierarchical controller brings in as a part of the stack. But before I get deeper into the CNC, let me also touch upon the cloud-based SaaS offers. And there are three flavors. One is the Network Insight, which is built on the BGP model technology and helps to track the routing anomalies, where you can detect the situations like the route leaks, route hijacks, or man-in-the-middle attack. Then we have the Traffic Insight, which helps to visualize, analyze, as well as optimize the traffic at the distributed peering points. And then Trust Insight helps in monitoring the trustworthiness of the infrastructure, where it's looking at the integrity of the devices, both at the hardware and the software level, and basically identifying whether the hardware is authentic, has the software been altered, and not just at the boot time, but also in the runtime, because it's able to consume the logs from IMA, which is Integrity Management Architecture, the logs coming from the device in the real time to track the integrity. So that's a glimpse into those, and let's now go deeper into the Crosswork Network Controller. Now, to introduce the controller, I think a good way is to talk about some of the challenges and the use cases that the controller helps to address.
Well,
Excuse me, I have a question.
okay.
Sure.
I'm Rita Younger, and I'm very familiar with Nexus Dashboard Insights. Where does that stop and this start? And it makes sense to me that there would be just one product instead of Crosswalk plus Nexus Dashboard Insights for the data center, and then Nexus Dashboard Insights also works. There's new Nexus Cloud, so I'm just seeing overlap between product.
So I think what you're referring to is the Nexus Dashboard, which is targeted for the deeper visibility into the data center.
Right.
Is that yeah.
Right, and there's also now Nexus Cloud as well, which has some of the same features.
So let me kind of clarify the positioning in terms of the CNC is more for the transport network, as we can see in this slide, which is connecting the data center edge on the right side to the access on a wide area or a metro area network. And that's what the focus of this solution is. Versus the Nexus, which is kind of looking at the data center in much deeper details.
Wouldn't it make more sense to have end-to-end visibility? So you've got from the access layer at the client side all the way through the data center and including cloud. I mean, I think that's something we've all been looking for a long time. So instead of just product that does campus and user access and product that does data center, one product, because there are so many overlapping features.
Yeah, no, so I think to the point that you're making, I think that when I talked about the hierarchical controller, it's helping in that direction, where bringing together the multiple domains to deliver an end-to-end view. Currently, it doesn't get to the data center, but that's a good point, but the direction is towards that end-to-end view. And you'll see in some of the use cases that even as we talk about splicing, that how we are aligning to some of the industry architectures that enable, through the open interface of these components, that if there are components in the portfolio that is connecting the domains, we should be able to stitch into it, whether it's a hierarchical controller or it could be another product that delivers that into visibility. The goal is to make sure that we have the open standards-based interfaces that helps to integrate with the existing other OSS components, whether it exists in a customer environment from Cisco or from other vendors.
Well, we've seen for a long time with Cisco that when one product's developed in one BU and another product's developed in another BU, and then they go to stitch them together, such as the multi-domain architecture, we never really get there. So wouldn't it make sense to develop from the beginning that it was going to be multi-domain and be end-to-end visibility instead of one for the data center and then one for the campus?
No, we can definitely discuss it because there are definitely architectural pros and cons, benefits, and things that has to be taken into account. At the same time, we want to make sure that the components are modular and can be, can help to address a wide range of use cases, both from functional and the deployment perspective. So that modularity and ability to connect is important. So, but definitely we can take on, further inputs from you, offline.
Okay, thank you.
Thank you. So, so going a little deeper in terms of, so I'll quickly go through some of the use cases we are addressing specifically when we position the CNC, and then I'll hand it over to Krishnan for a demo, going deeper into some of the magic that we do here. So yeah, as I was mentioning, so as in this transport network, as you're delivering services like the L2, L3 VPNs, one of the challenges we have today is that the customers have to spend significant amount of time. It could even take many weeks to provision a service because they have to go deeper into the networks, into the configuration from multiple vendors to then push what is needed to provision an end-to-end multi-point services. So that's where you need this controller where it can be done in a more intent-based automated fashion, where, as I was mentioning, that you can express the intent in the YANG model, like a service model, and then it gets orchestrated across multiple domains, right? So that's one of the key. The second one is, like, as you know today, like on the infrastructure, we have many different services that are running. Some of them are more latency sensitive, some of them bandwidth intensive, transactional, and so on. Of course, we do expect there would be fluctuations in the traffic, and that fluctuation could always cause congestions. So what happens there? The customers may over provision the network, but that's like increases the cost. But really what is needed is a controller that can help to quickly react to these fluctuations through its real-time monitoring and optimization capabilities. So that way you can always be on top of the network, what is needed. And then thirdly, like what about if there is service? So if there is a topology change or if there are certain alerts that could indicate that there's a degradation of the service, we are constantly monitoring the network, and the controller helps in taking appropriate step, whether it's related to remediation or optimization, to implement what we call as a closed loop optimization that you'll see today. And lastly, I want to also mention is because I talk about so many different functions, often again to the point we were discussing before, you'll probably see there are many different tools. There's one tool which does provisioning, another one which does assurance, and another one which does visualization or optimization. What we are bringing together, all these under one UI, so that it can eliminate some of the islands of fragmented visibility that is actually impedes the operational agility. So that is taken care of. That's already a significant step to the conversation we had in terms of bringing these functions as one user experience. And you'll see it in the demo as I hand it over to Krishnan now, so you can see the product in action.
My name is Krishnan Thirakonda. I am a principal engineer in the Crosswork Technical Marketing and Product team. So to connect the dots here, right, we're talking about transport networks. I think there was a question earlier, why can't we have one tool that, does all the way from campus to data center, and also the WAN network that exists between all of those, right? That's an ideal outcome, but it's going to be aspirational for a very long time, right? Because these technologies, evolve independently. There are domain of control, meaning the WAN staff decides independently what kinds of hardware they're buying, what technologies they want to invest in, and so on. So the Cisco strategy is that we have data center controllers, we have transport. We think of it as WAN transport, and then we have subscriber control automation solutions, and then we have a hierarchical layer where we can present everything together. But even just looking at transport networks, the approach now we have taken is a SDN controller-based approach, where a single controller is managing that network, managing in the sense of looking at the blue boxes on the left, service turn-up, right? You want to get your service up as quickly as possible. These are usually the transport networking. layer, it's some kind of VPN, right, or internet access, right? VPNs, L3 VPNs, L2 VPNs, reachability, those things. Now, those things have been around for a while, and large customers, either enterprises or service providers, they have more. Let's put it this way: need to differentiate or more specific SLA requirements, right? Those things are usually implemented using traffic engineering technologies, right? That's what in this slide we are calling as service-oriented transport provisioning. Think of it as the underlay, right? Normally, these are just IP underlays, and you run overlay VPNs, L3 VPNs, L2 VPNs, using VPN v4, v6, or your EVPN, or legacy L2 VPN technologies. But now, when I say now, I mean, the segment routing traffic engineering has really revolutionized this space, right? You get a lot more control, a lot more granularity. RSVPT was the legacy traffic engineering protocol, and you could deploy, but it was really hard to deploy, mainly from operational reasons, and it doesn't also scale. I mean, you can do pervasive everywhere, every service RSVPT. Typically, it was done P2P full mesh for getting benefits of fast reroute, and maybe a few services you can create some lanes of traffic. But with segment routing, this becomes very scalable, both from router ASIC scalability and protocol scalability, as well as operational scalability. But why is it so scalable? Because it adopts what is called a source routing paradigm, where the controller becomes very important, right? The controller is doing the path calculation. It has full visibility of network. And now you can actually just, as an intent, express that I want the least, latency path, or I want a path that is totally disjoint from another path, so that I get, node and link redundancy, right? All of those things can be easily expressed. In the past, you would do tools offline. You'll figure out which are the hop by hop paths and nail up paths. So that piece is very important. And what we are trying to do with CNC is to build the whole path compute component and enable binding it to a actual end offering, a VPN offering, in a seamless workflow and experience, not only from service turn-up, create, update, delete perspective, but also from day two, how do you actually get visibility of, which path is your VPN taking, and is it still meeting the SLA, right? So that becomes very critical when you bring in these technologies and you want to turn up services and respond to customers quickly. Once you deploy these services, you want to do real-time optimization. So this is very important as well. If you're going to offer more granular SLAs, how do you know that those SLAs can be met when the network keeps changing? And this is going to happen, right? Every network has link and node outages, and you want your SLA, if you offered a what we call as a lowest latency or a disjointness or a policy-based affinity to certain paths, a government traffic has to run only on MACsec. How can you ensure that happens even when the network changes without resorting to nailing up paths? If you nail up paths, when the path goes down, you want somebody to go and manually figure out which path. That doesn't work, right? I mean, this is, you'll have days or hours and days of outage. You really want the network to do this all the time. So that's the real-time network optimization, and that we do through CNC. So dynamic traffic engineering, this is where we can express our intents in different ways, right? We can have different constraints. The simple ones are, of course, IGP cost and latency and things like that. But we have also introduced, and this will be covered in the next presenter, the flexible algorithm, right? This is a very simplified way of breaking up your network into different lanes with different SLAs. And then congestion mitigation. So congestion mitigation is a very innovative topic in itself and requires a little bit more discussion, and we'll offer further webinars on this, to explain how our approach is. But in short, when there is a congestion on a link, we can actually create bypass SR policies to bypass the congested link and basically move traffic that is usually best effort, that is not in any policy already, into those bypass tunnels and relieve congestion hotspots. So this reduces the need to constantly be upgrading your links and speeds and feeds, as they call it, you just get a little bit more time, right? You can react on a more planned manner. You can see the prediction of traffic going up and go, procure extra lines and, WAN links and things of that nature. But if you get a hotspot on a, busy day of the, of the year, you don't have to go, take the poor customer experience feedback, right? You can actually protect your premium traffic using this feature. And then the main thing from the day two perspective, once you've deployed all of this, how do you let your operations team be very reactive in a very quick manner, right? You don't want your customers to call in and then, takes a long time for the operations staff to know what's going on. One thing as humans we know is that visualization is very useful, and network engineers like to think of networks as topology diagrams. So I'll show you that in our demo. And then we have service health monitoring, which we'll cover in a separate section, and network monitoring, which also is a new thing that we're adding.
I have a question for you.
Yeah,
And this one actually came from Eric in Madison, Wisconsin. He wants to know if this is targeted primarily towards the service provider space.
It's targeted for anybody that's running a large network. We have quite a few large financial customers, and of course our SP service provider customers as well.
Okay.
We have anywhere from 200 router networks to 25,000 router networks. So we are trying to address a vast range here. The main customers pushing us is of course the higher end, I would say. So going a quick glimpse about how we build this product, right? One of the key, going back to the question that was asked, a lot of our customers want to build a multi-vendor network. Now, multi-vendor network brings in its own challenges. And this is something peculiar to, I guess, our large customers and our SP customers compared to our smaller customers, which is why if you look at how our ACI for data center and DNAC for our campus networks, those things are built in a batteries included kind of a approach where we control every Cisco device in the network in those domains. But when we come and look at this architecture, we are trying to do it in a standards-based interface. First, meaning all of these interfaces down south to the routers are very standards based, and we should be able to work with any router vendor. So that's our one of the major, let's say, first priority, right? And then we are building applications. From the top, if you look, you want to abstract all of the things that you want to do on your network using a unified UI, northbound interface, right? And so the main idea is, like we talked about earlier, that when we solve the transport problem and you solve the data center problem and you solve the access problem and you solve the cellular like 5G problem, which is where slicing and other things are coming in, you do want this higher layer, a workflow engine or a common hierarchical visualization tool to be able to consume all of these services through APIs, right? So that's where a lot of our customers are going. So that's how we are building our product as well. In fact, some of these northbound interfaces have their own model standardization going on. And there is an IETF layer 3 network model. There's an IETF layer 2 network model. There's a traffic engineering slicing network model. And then in terms of the implementation, we have this blue box that you see, which is a scalable microservices-based implementation. It's basically a Kubernetes cluster, and then we have apps on it. We have adopted all the cloud-native principles here. And then we have best-of-breed components down below. They run as independent VMs. SRPC is iOS XR 9000. It can be a hardware router if you really choose to run it like that. And the protocols are PSAP and BGP link state, which are standards-based, so we should be able to interop with any of the other vendor routers. We do interop testing with ENTC, and some of the results are read out in the SDN World Congress every year or every other year. And then the right side NSO is a best-of-breed provisioning and orchestration tool. It's a configuration engine. So not only we include it, bundle it both in commercial terms as well as the images and things like that. We also give you the VPN provisioning and the SRT provisioning packages with it. And then the data collection layer is another innovation where we can actually have a scalable data collection to collect telemetry to do the applications that we need to achieve our goals, right? So let me switch to the demo, and I'll quickly show you the UI, and then we'll go through the multi-vendor provisioning. And I'll mention that we have, now new support. This is 4.1 innovations, ELAN and E3. By the way, these services are all extensible at any time. What we are trying to do here is out of box, we're trying to add more and more library of flavors of VPNs. And one of the goals with that is to see if we need to improve our visualization, right? So we're adding those libraries of services and the visualization that go with it. And network monitoring is basically taking basic network monitoring, like, is the router have any syslog or trap coming out, starting to collect those. In the past, that was a purely element management function done by EP&M, but we are slowly moving over some of those functions as well. So I'll go ahead and introduce the multi-vendor, demo. This is the CNC UI, and you can see here that this is the dashboard. The way it works is that CNC, as we mentioned earlier, it can do VPNs, it can do SRTE, it can do maintenance workflows, it can do KPI collection. So the screen has a concept of dashboards, right? So the first one is basically a summary of all the traffic engineering things we do. And then you have VPN services, you have device status, and service health, right? So service health we'll cover in another section later today. This is the Kubernetes cluster details, the infrastructure of Crosswork itself. So you have the cluster, and then you have the software components that are installed. We have about 8 components that you can independently install depending on the features you want and the license levels, right? So just to show that we are very modular. Let's go ahead and look at the provisioning screen, which is where most of the actions happen. As explained, we do the L2, L3 VPNs and different kinds of TE technologies, SRT and RSVPTE. And these are the areas where you would go in, for example, to create an SRT policy, you'd go ahead and click add, and then you would go ahead and give it a name. And it basically what it does is it takes the model, the SRT model that we have, and exposes it as a forms-based interface. You can fill this in here. We will not do that. And we'll go ahead and show. Now, let me show you the topology here. This topology was learned using BGP link state, right? So we run BGP link state with every ISIS or OSPF domain, so we can scale beyond just one domain. And that's where the scalability from segment routing perspective comes in. There is a PCE, path compute element, that's sitting and peering with every OSPF and ISIS domain through BGP link state, one router, and at least one router, preferably 2 routers running BGP link state and feeding the whole link state database to our the PCE, which is also based on XR, but it's running inside the Crosswork complex. And then we have integration with that, so we can look at the LSDB and figure out and render this topology. And at the same time, we allow you to add metadata, like which city or latitude, longitude it's located, so that we can render this in a map, right? And on top of it, we start collecting SNMP-based telemetry, right? So these links are colored green, yellow, orange based on what we have measured as the traffic going through it. These color levels can be set depending on your thresholds that you want to be warned about. For example, yellow in this case, this is a very small lab with all XR 9000, so I have set the thresholds really low to show you the coloring, right? Again, how do we collect this? As soon as we detect these links and these routers are onboarded, we start SNMP. Today we use SNMP. We are moving to a GNMI, all GNMI based architecture, where we can collect these interface counters, and then knowing that they are like 1 gigi link or 10 gigi, we can take your thresholds and color them appropriately. Now, one interesting thing to show here is that there is a router on the top. All of the node routers are all Cisco XR, but this VMX99 is a different vendor router. So let's go ahead and take a more look at it. So let's take a look at what that router is, and so it's a VMX. And for those who are familiar with our other vendor that's out there, and it's basically a Junos router, right? So it's running Junos. We're able to detect that and show in the same view. Let's go ahead and look at a little bit more detail. So that's the VMX99, and if you look at all we have fed into the system is the SSH. and the SNMP, how to access it, and the credentials, right? We are able to go ahead and connect to it and display it on the topology, and we can do SNMP queries to find out who the vendor is, what the software is running on it. So that's the starting point. Now let's go ahead and provision a SRT policy. And first, let's see that there is no policy created at this point. We're going to create from VMX 99 to Node 4, Node 4 being an ISXR router. When you click create, you can see there are two choices. One is PC init, which is using PSEP, but we are going to actually configure the Junos router. So let's go ahead and load the, we can actually load the JSON payloads that you would send through API onto the UI as well. So that makes it really convenient to just fill in this forms-based interface that I was showing you earlier. So that's a policy we're creating. The head end is going to be this router. That's the tail end. That's a color. Here's the candidate paths. You can give a number of them. Here's a constraint that we actually support, which is bandwidth. In this case, I'm not going to create bandwidth, but I'm just going to create a simple dynamic path calculation based. Here's the intent. We do support explicit as well. Here you would give a all the segments that you want to go through. That's a nailed up thing. But here we're going to do a dynamic with PCE doing the path calculation, right? So each router has some day zero config where you say who's the PCE. Here are all the constraints we support for metric type, and disjoint and affinities are also supported. This is all, by the way, standard segment routing. A lot of the vendors are supporting it, and it's all standardized, meaning most people want these kind of things. So all we are doing through Crosswork is enabling you to push these configs, right? So affinity is another one that's very popular. Now, once you created all these things, this is where the intent is, and you click dry run, you can see actually what the config will be pushed on the router. And again, this is where the power of NSO, there's an NSO running underneath, which is the configuration engine. It takes the northbound model entries and calculates for that particular type of router. In this case, it's a Junos, the actual config needed. And NSO, I think some of you are familiar, but it's basically a model-based tool with a translation layer. And you create a template, and then you map the northbound entries to the southbound exact configuration model entries, right? That's what happened there. Once you provision it, basically the router is going to get provisioned. And if you go back and look at, it'll show up in the traffic engineering, right? Now, what can you get from visualization perspective? You click the policy you want to view. You can see the segments it's going through, right? You can see adjacency sets. All of those are highlighted. Each segment may have multiple IGP hops, but in this small test bed, it's turns out each segment is just one hop. You can go into view details. This is what the escalation engineer that's dealing with a SRTE issue is going to want to look at. But as you can see, he doesn't have to log into every router. He doesn't need credentials to every router in the whole large network. He can quickly go and look at all this stuff. It's literally at his fingertips in a few clicks, right? This is very important for any kind of a troubleshooting escalation to understand what's happening on your network. So let's continue here. So you can see here, this is what we created, on the VMX. And see, now we added also in 4.1 historical data. Here you can see anytime a path changes, you can click and see the path at that time. And in this case, I don't have traffic, but if you have traffic, you can also see the traffic going through that particular SRT policy. Now, the main benefit is that when you create VPN, so let's go ahead and create a VPN. There are no VPNs now, so I'll go ahead and provision a VPN. And in this case, what we'll do, we'll go ahead and load a payload for a L3 VPN. And let's see this. So once it loads, you'll see that there are 4 sites, PEs, if you will. There are 3 Cisco and 1 Junos router here. And then the IETF profile. This is, by the way, IETF model. So you'll see that all the route distinguisher, route targets, and the policy that you are applying, it's all defined once, and every PE can just import it. VPN 101 route policy I'm applying here. And then if you go into the VPN nodes, this is where per PE information can be specified, where you can override those route targets if you want. But typically you give things like PEC, addresses, and your PEC routing protocols and things of that nature, right? So that's that comes in here. And then you can do a dry run again. This is where you're asking NSO underneath to do the calculation for the configs that will be actually pushed. You review it, and let's go down to the Junos router just to show the multi-vendor piece. So you can see, if you're familiar with Junos, you'll see that we are actually, we created this template for for this demo to show you that we can do that very easily as well, right? The idea is that the platform itself is built to be extensible, and you get out of box for Cisco. For any other vendor, it can be implemented in the field by our professional services or customers, because a lot of our customers actually do NSO-based extensions. So this is the visualization you get. So let's pause here for a second. So now this is the VPN visualization. It has 4 sites, and then we show this kind of visualization with some kind of unique identifier of what that VPN is about. In this case, we chose to show route target as the unique thing. By the way, this we have a whole, we call it SDK, software development kit, but it's really a developer API where you can actually look at the NSO's config DB, and you can choose what things you want to label on the visualization. And we have a Python and Java-based API to do that. And all you have to do is you have to go and you download the SDK, you take the NSO model, and you say that these are the fields I want to use as labels. And we have some build tools that will build and push the what we call as the active topology function pack. This component that's doing visualization is called Crosswork Active Topology, and then you get this this kind of visualization that is sitting on top of the NSO's config DB, right? So I went through a lot of detail here, but basically the idea is that NSO has a config DB, it has a model, and then the visualization has its own model. In that model, it's just like circles and lines and labels, right? Think of it as a decoration model. And what you're doing is you're telling the visualization model to look at these NSO YANG model leaves to pick out items and show them. So we did some live demos of this in our automation developer days, and I have some links in the slide here that you can look at for learning about it. But let me go through a little bit more things. So in 4.1, we added a way to actually see the CE devices. This could be logical CEs, meaning they are just BGP session to a CE that's been configured. If you have a fully managed CE, it can be those as well. If you go into view details, you can see a lot more things here. Here's a payload that we actually pushed in the JSON file that I loaded in the UI. You can send this exact payload through API. We have demos using Postman, but now that we can load these things in the UI, we are showing it through UI. But this is what you would give your higher level integration, the hierarchical controller or the workflow engine or business system that's going to provision. Those developers, their job is made easier because you can see that, this is what they need, right? They need to decide, for example, what policy they want to apply and things like that. But that's really the business intent, right? And here's the policy we applied. This is how segment routing on-demand next hop works. You take a bunch of prefixes, VPN 4 prefixes in this case, because we're doing L3 VPN, and then you apply a BGP color community. We are applying 4001 and 4003. And then we also have something called on-demand next hop templates. These are, again, ODN technologies, which says that put this template that brings up SRT policies when you get a BGP color community, right? And so we have 2 of those, 4001 and 4003. We put them on the 3 Cisco and the Junos router. And then if you go to transport, you'll see that magically, because of the BGP VPN v4 routes come in with the color community, all of those routers headends brought up SR policies on demand, right? And this is, again, you can see the 3 policies from the Junos as a head end. And you can click on it and see the visualization, which exact segment hops it goes through for these 2 tail ends. Again, you can look at the resolved path, meaning the IGP paths for those segments, and you can get all of that in this view. You can actually click on the 3 dots on the right to get a lot more details. We also show you a lot of hovering details about the SRTE details that were created. As you can see in this case, Junos is creating paths. By the way, we could have done bandwidth on demand if we wanted, but we did choose to, so it's 0. And this is how Junos creates paths. This is their format. It starts from tail end, the color in the hex, and then the what they call as source route template name, right, which we have created through the provisioning workflow. And then you can see the segment identifiers and things like that, all the details.
So I'm not as familiar with the NSO component. Do you have to select the specific southbound method you're going to use, or can you have a pre-set up list of what you want the controller to use to try to contact devices, and it'll just pick whichever one in order.
Okay, so that's sorry, was somebody else saying something?
No.
Okay, sorry, I thought I heard something. Yeah, that gets into how NSO works. So NSO has a concept of your intent, which is a northbound model, like a VPN model, which is device agnostic, and then it has a per device, let's say device type. They call it NED, network element driver. So basically, it's a device model, right? When you onboard a device, you say which model you want to use. And for Cisco XR, for example, we have two kinds of models. We have the CLI model and the netconf model, right? We support both. We support both, meaning NSO supports both and CNC supports both, right? When you click through CNC. So basically, to answer your short answer to your question is, when you onboard a device, you actually pick, let me go to devices here. So you actually pick, what kind of model you want to use for these devices. And then it becomes, the translation layer, which is translating from VPN to the device model, knows how to translate it.
Okay, and that's what I was trying to figure out for when you're talking about multi-vendor support. Whereas a Cisco device, is it maybe just going to choose netconf first versus a different vendor like Juniper? It'll go through and it'll do SSH to the device directly. That's what I was kind of trying to get at.
Exactly. So what we do is, as soon as you onboard a device here, we do SNMP. Today we do SNMP. We can look at doing open config or GNMI based things. But as soon as we know it's iOS XR 771, we know that because we just query SNMP system mib. Then we go and see there is actually a policy that's not shown here, but you can actually set up policy saying if you go into settings somewhere, it's there, that for this type of router, Cisco iOS XR of this version, run this particular network element driver, and it'll basically onboard that type of router and that type of a device model, I should say. And then the translation layer will be able to handle the translation to that particular model.
Okay, thank you.
Sure. If no other questions, I just wanted to give a quick glimpse of, like I said earlier, we added a bunch of, we keep expanding the suite of L2 VPNs and L3 VPNs on the visualization. So I want to quickly, instead of going through the provisioning flow because I'm over time here. So this is the L2 VPN ELAN that we support. So you can now create EVPN ELANs here, and then we show a multi-point because it's a multi-point bridge. And then you can go into view details. It has a very similar experience to L3 VPN. And here's the payload that we created. Here's the transport layer where the tunnels came up. I used color 4501. And here's one more thing to show before I pause, which is E3, right? So this is L2 VPN ELAN E3. So we, this has a hub and spoke model, and so we added these visualizations, little hub and spoke stamps here.